Hello everyone. In this video, we will start discussing a very important topic in programming, which is arrays. So arrays are extremely important because you can store many data in a single variable. And one way to write an array in MATLAB is in the following syntax. For example, I can write the array X. I open square brackets as you see here and enter a set of numbers, for example, 1, 4, -1, 0, 2. So this is an array that contains 5 elements. So I can hit enter here, and as you see here, MATLAB repeats that this is an array containing 5 elements. They are all double, so they are all considered as double real numbers, and the size of the array is 40 bytes as you see, which you can calculate by multiplying 8 bytes per element times the 5 elements we have, and that gives you 40 bytes. So this is a horizontal array. Another way to call arrays, you can refer to them as one-dimensional arrays. One-dimensional arrays. They are one-dimensional because, as you see here, there is only one line of elements, one next to each other, or you could refer to them also as vectors. So you can consider these as vectors with some analogy to vectors in physics. And we will get to that soon in this video. Sometimes you want your array to be vertical rather than horizontal. It's still one-dimensional, but you want it vertical. And you can do this in two ways. Either you write it horizontal first and then transpose, and that happens with this little sign here. So with this transpose, you get the x transposed or becoming vertical instead of horizontal, or you could alternatively type your array with 1 semicolon 4 semicolon -1 semicolon 0 and then semicolon 2, and this way you get your array in a vertical arrangement. All right. So these are different ways to enter to input one-dimensional arrays in MATLAB. Another thing you can do with arrays is the so-called appending. So let's actually learn this new concept, which is appending, which could be useful in some programming problems. So let's clear here. Suppose we have the X array that we wrote before. Let me actually transpose it back to be horizontal one more time. In fact, we will be dealing most of the time in this course until we reach to matrices, we will be dealing with horizontal arrays. So suppose this is our X now. In fact, let me put it this way, y equal the answer. So now y is horizontal. I can define another array Z. Let me put it 2 elements. So -1 and maybe 4. And then I can append Z, Y, and generate a newer array with more elements. So remember, Y has 5 elements. So let's remember Y has 5 elements and Z has 2 elements. So I can create an array W that contains the first 5 elements are those of Y, and then the next 2 elements are those of Z, and this happens by appending in this fashion. And if I hit enter, you get exactly what we described, an array with 7 elements. The first 5 are coming from Y, and the next 2 are coming from Z. So let's clear a little bit and try to discuss the array W. So sometimes you also are interested in referring to certain element. So for example, this element is element number 1 in the array. So its index is element number 1. So I can refer to it W of 1 in this fashion. And if I type enter, it will give me the value of 1. The second element is 4. And if I want to refer to it, this is going to be W of 2 because it's the second element in the array. And again, if I hit enter, that gives me 4. Finally, this array has 7 elements. So if I type W of 7, the last element, which is here, which is also 4, actually the last element here, I'll get the same answer. Okay, so W of 7 equals 4. clear and bring W one more time. If you try to type W of 8, of course, this array contains only 7 elements, you will get an error message. Index exceeds the number of array elements. Usually, when you see this message, it's like you are trying to calculate something for an element which is beyond the array size. And speaking of the array size, there is a very useful command in MATLAB that can tell you how many elements exist in this array. And this could be very, very useful in several programming situations. And that command is length. If I type length of W, it will give me 7 because there are 7 elements in W. And if you remember the array Z, again, let me remind you of the array Z. If I type length of Z, I will get 2 because there are 2 elements in the array Z. So, and so on and so forth. So length is a very, very useful command that allows you to know how many elements in this array. But I want to get back a little bit. Maybe let me clear and write the array W one more time. We learned how to refer to each element in the array. And in fact, you can do computations, you can do arithmetic on these element by element references inside the arrays. For example, I can write the expression W of 1 plus 2 times maybe W of 3, maybe minus W of 5. And again, let's see how this is computed. W of 1 is 1, so this is like 1, plus 2 times W of 3, which is negative 1, as you see here. So it's times negative 1. And then minus W of 5. Where is the fifth element? It is actually 2. So it's minus 2. And if you do this algebraic calculations, this is going to give you negative 4 plus 1. That's actually negative 3. Let's see how MATLAB will calculate this. It's also negative 3, confirming our calculation. So you can do arithmetic on element by element inside the array. And this will be quite useful as we discuss the next problems and ideas in programming. The final thing we would like to discuss here is the fact that you can refer to arrays as vectors. And this is useful when we solve certain problems in mechanics or physics. So remember, in physics, I can refer to a vector V with its component in the I direction. So maybe, for example, 3i minus 2j plus 4k. Remember, I, j, and k are the unit vectors in the x and y, z axes or directions. So you could consider an array, a one-dimensional array like V equals, containing these 3 components, the 3, negative 2, the 4, representing a vector in physics. So this could be a vector in physics. Similarly, I could have another vector, let's say, for example, array or vector W, the vector W, or let's actually refrain from W because we have a W here before. Let's call it Q maybe. So Q, it could be, for example, R, 4 in I direction, plus 7 in J direction, and maybe that's it. Okay, so in that case, I can represent this here in 3-dimensional space. So it will be 4, 7, and because we said in 3-dimensional space, the Z component here actually happened to be 0. So that's vector Q. So MATLAB offers you 2 very useful built-in functions. Those are the dot built-in function and the cross built-in function. So the dot calculates the dot product. So this allows you to calculate V dot Q. And you know from mechanics that the dot product result should be a scalar, right? So I can actually test it here. So if I type dot V comma Q, it will calculate the dot product, which is negative 2. If you remember from the theory of mechanics, this is basically like 3 times 4, right? So this is 3 times 4, which is 12, plus negative 2 times 7, that's negative 14. And then plus 4 times 0, so which is 0, and that gives you the -2 that you see here. You can also do cross product. And again, if you remember from mechanics, the notation for this cross product is given by V cross Q, and the result is usually a vector. And without going into the details, if you remember how to calculate this vector, you use determinants. For example, you list here I, J, K, and you list the components of V, 3, -2, 4, and the components of Q, and these are actually here 4, 7, 0. And of course, you can do the basic determinants algebra to calculate the result, but MATLAB offers you this capability by the cross function. So if you type cross V and Q, that actually gives you the vector -28 in I, plus 16 in J, and 29 in K. And we can confirm certain property. Let's actually move to another page here. We can confirm certain property from the theory of vectors that V cross Q equals -Q cross V. In fact, let's test this together. So cross Q comma V here. So as you see here, it gives you the same vector with a negative sign, confirming what we have learned in mechanics. So in summary, we learned how to represent one-dimensional arrays, and usually this requires the square brackets and listing of the elements. You will learn other more efficient methods to generate especially larger arrays, but as we progress in the course, you can look at these arrays as vectors. You can append them together. So if X is an array and Y is an array, you can generate a new one, Z, by appending X and Y. You can start referring to each element in the array. For example, you can refer to the first element in array Z as Z of 1, Z of 2, that's the second element, and so on and so forth. There's a very useful function called length that allows you to see how many elements exist in a certain array. We also looked at arrays as vectors. And MATLAB offers you two very useful functions, the dot and the cross functions, to calculate dot and cross products for vectors. Thank you so much, and see you in another video.